You are definitely going to be asked a question like this on Thursday. So put a star next to this when it comes to reviewing because this is going to be important, okay? Finding the inverse of a function that's x squared, okay? I'm looking for a quadratic inverse. You may be thinking to yourself, okay, well, I already know it's going to involve a square root somehow, but you need to be familiar with the process of how to find an inverse of this, okay? There's step process behind finding an inverse, okay? The first things first, since genuinely everybody recognizes that f of x is the same thing as y, just in function notation, we want to make sure that we make this substitution first. It's not a dire step, but it's in making our answer, it's pretty important to do first. The second step is flip x and y. Okay. Next step, solve for y. Okay, when you finally solve for y, the last step is going to be change y to this inverse notation, okay? If you don't have this, it'll dock you points, okay? Because y was the same thing as it was before, so we want to make sure that we decipher it between whether or not it's the inverse of the original function, okay? So let's do an example. So let's say I've got something like f of x equals 3x squared minus 1. How would I find the inverse? Well, first step, I'm going to make sure that I change this to a y, so it's a little easier to work with. Okay. Now I'm going to flip x and y, so this is going to give me x equals 3y squared minus 1. Now I'm going to solve for my new y, okay? So I'm going to add 1 to both sides. So I get 3y squared equals x plus 1. I need to divide by 3 on both sides, okay? So I get y squared equals x plus 1 over 3. Finally, I'm going to move up to the top. So I have y squared equals x plus 1 over 3. To undo the squared operation, I'm going to square root both sides. Y equals root x plus 1 over 3. Okay? We saw something before about this thing called restricting your domain. Okay, because when you square root something, you're technically supposed to have a plus or minus, okay? But in actuality, if we restrict our domain, which making it x greater than or equal to 0, we only care about the positive part, okay? So this y right here is our inverse, so I need to replace it with the inverse notation. Okay, that's how you would find the inverse of that specific quadratic. Okay, so your turn. So try this one yourself before looking at how I got the answer out. I'm gonna have negative 2x squared plus 6. Okay, so try that first and then see if your work matches up with mine. Okay, so I'm gonna replace f of x with y. Negative 2x squared plus 6. Switch x and y. Negative 2y squared plus 6. Subtract 6 over. So I get negative 2y squared equals x minus 6. Divide by negative 2. So I'm going to move up to the top here. Y squared equals negative x minus 6 over 2. Then I'm going to square root both sides. So I got y equals square root negative x minus 6 over 2. That negative is on the side of the fraction, okay? You could put it with the negative 2 if you want, or you can keep it on the side. It doesn't matter, okay? And since I'm going to restrict my domain to x is greater than or equal to 0, I only care about the positive root, okay? So now my inverse, I'm going to replace the y with the inverse notation, which gives me f inverse of x being equal to the square root x minus 6 over 2 with that negative in there. Okay? That's how you would find the inverse of that quadratic. Okay? We also did for cubics. Okay? I'm not going to go through the steps because we already have those. So I'm going to basically give you some examples of cubic ones. Okay? So let's say I've got f of x equals 2x cubed minus 1. How would I find the inverse of that? It's the same process. Okay? So I'm going to make this become a y. 2x cubed minus 1. Flip x and y. Now my goal is to solve for my new y. I'm going to add 1 to both sides. Remember, undo the operation that isn't connected to y first, okay, which is that -1. So I'm going to add 1 to both sides. I'm going to move up top here. 2y cubed equals x plus 1. I'm going to divide by 2. So I get y cubed equals x plus 1 over 2. Now, to undo a cube operation, you cube root both sides. Okay, so I get y equals the cubed root x plus 1 over 2. I'm going to replace this y with the inverse notation, and that will be my inverse. Okay, so going up top here, I've got f inverse of x is equal to the cubed root x plus 1 over 2. Okay, that's how you would find the inverse of a cubic. So I'm going to give you an example, and I'm going to want you to try it yourself without looking at what I have. So let's say I give you the function f of x equals -5x cubed minus 1. Go ahead and try that yourself, find the inverse of that one, and then convene back to the video and see if your answer was correct. Okay, so first step, make that a y. Okay. I'm going to flip x and y, solve for my new y. I'm going to go up top over here. So I'm going to add 1 to both sides. I get -5y cubed equals x plus 1. I'm going to divide by -5 on both sides. Y cubed equals x plus 1 over -5. I'm going to cubed root both sides. Okay, that cube root goes to the top and the bottom. So I'm left with y being the cubed root x plus 1 over, that's plus positive 1 over -5. Okay, now I'm going to replace that y with f inverse, and I'm done. This is going to be the cubed root x plus 1 over -5. Make sure that root goes over the whole fraction. And that's my inverse. So that's how you find the inverse of a quadratic and a cubic. I encourage you to try and make your own equations. You can literally make it whatever you want. You're going to get an answer out. Okay? Just make sure you have an x cubed and a constant. Find the inverse of it, practice it. This should be something that is relatively straightforward to get pretty good at.